Dear session chair, dear participants, I'm Sena Ardicli from Bursa Uludağ University, Faculty of Veterinary Medicine, Department of Genetics. Today I'm going to give a presentation entitled Association of the Sterile CoA desatrase, annexin A9, thyroglobulin, hormone-sensitive lipase, and protein kinase AMP activated non-catalytic subunit gamma-3 gene polymorphisms with carcass and fattening performance traits in Simmental cattle. First of all, I want to start my presentation with the general outlines. In introduction section, I will talk about selecting animal material and effective ways to improve fattening performance and carcass traits through molecular biology techniques and use of genetic markers, and the candidate genes and the aim of the study, and in material methods, the phenotypic data, genotypic methods, and statistical analysis will be discussed. And in results and discussion, I will give information about allelic and gene frequencies, population genetic indices, and phenotypic traits. And I will finish my presentation with the conclusions and suggestions. Simmental, as a versatile breed, is one of the oldest and also the most widely distributed breed in the world. The importance of Simmental breed, besides its high milk yield and reproduction performance, is also seen in achieving high fattening performance and disease resistance. Fattening performance is a very complex trait and is regulated by many genes. Selection of animals with better performance and higher meat yield is one of the main objectives for breeders and beef farms. The majority of meat yield has a genetic as well as environmental component with varying heritability. These traits are quite complex and are affected by housing type, season, initial weight, concentrate level, sex, and pen cattle population. In addition, the optimal slaughter ages and final weights vary widely among cattle breed types. Determining expected yield and quality of meat that emerge in the later stages of life can be facilitated increasingly by the use of molecular studies. A number of candidate genes have been identified as potentially associated with fattening performance and carcass traits, varying on the specific trait analyzed. Improved breeding methods as well as the application of biotechnology have advanced the efficiency of cattle production. The genotypic selection is far more effective than phenotypic selection in complex traits such as fattening performance and carcass traits. Recently, many pieces of evidence have been presented that show the fattening performance and carcass traits are rather influenced by a number of candidate genes and genotypic markers in various cattle breeds. Thus, many commercial SMP chips, arrays, and panels have been developed. In many developed countries, such as USA, Canada, and European countries, animal production strategies are based on molecular techniques and genomic approaches. In this study, sterile CoA desatrase, annexin A9, thyroglobulin, hormone-sensitive lipase, and protein kinase AMP-activated non-catalytic subunit gamma-3 genes are considered. All these genes have been shown to be important in regulating fat and muscle metabolism of cattle. To get lower time, I will use the abbreviation of these genes in the presentation. So we based the study on the association of polymorphisms at the selected genes with fattening performance and carcass traits belonging to Simmental bulls breeding in South Marmara region of Turkey. A total of 72 purebred Simmental bulls were used, and all of them were bred under same management conditions, and the initial average body weight of the animals were 200.21 kilograms. When animals reached appropriate slaughter maturity, the final weight was determined and they were slaughtered in the same commercial slaughterhouse according to standard routines. To determine the fattening performance, initial weight, final weight, fattening periods, total weight gain, and average daily weight gain were evaluated. For carcass traits, hot carcass weight was measured after slaughter, and the chilled carcass weight and chilling loss were recorded after 24 hours at 2 centigrade degrees. The dressing percentage was calculated based on both hot and chilled carcass weight. DNA extraction was performed using a phenol chloroform method by using the blood samples. The amount and purity of DNA samples were measured with a spectrophotometer, and polymorphisms at the candidate genes were examined with the PCR-RFLP method. The digesting products were then electrophoresed in 3% agarose gel at 85 to 90 volts for 1 hour and photographed with a gel imaging system. The association between the genotypes and carcass and fattening performance rates was analyzed using the least squares method as applied in a general linear model procedure of Minitab software. The appropriate statistical models were chosen based on the R-square values. Results revealed that all of the markers studied were polymorphic according to the minor allowed frequencies. The SCD and HSL markers show the deviation from the Hardy-Weinberg equilibrium. In PRCAC3, the GG genotype frequency was found to be rather low, resulting in lower genetic variability and the values of population genetic indices. In the various analyses, the TG was significantly associated with final weight, total weight gain, average daily weight gain, and hot and chilled carcass weights. The SCD gene significantly affected the final weight, total weight gain, and average daily weight gain. Moreover, HSL was significantly associated with chilling loss. There was no association between ANXA9 and PRCAC3 markers with the traits analyzed. On the other hand, the fattening period and dressing percentage were not affected by any of the genotypic markers. It's important to note that TG square SCD genotypic introduction was found to be a very effective determinant in the evaluation of not only fattening performance rate, but also carcass weights. So as conclusions, in this study, fattening performance rates differentiated concerning bovine TG and SCD genotypes in Simmental bulls. HSL was significantly associated with chilling loss, and the TG square SCD was found to be a very effective genotypic interaction. Fat metabolism related genes should be considered when evaluating fattening performance in selection programs, and consequently, information on polymorphisms of the tested SNPs and significant associations may be used to improve selected traits in beef production. Thank you for listening to me.